We are going to kind of go through what we have been doing the last 3 days in the lab. We can start with the beginners group and just do a recap of the different steps and what we ended up with. And then you have the opportunity to ask questions if there's something you are wondering about.
Well, these are the samples that we worked. We had 8 samples, and they were divided in 6 of them standard input amount, and 2 of them, the krill, was supposed to be a low input amount, but it was similar to the other. So because one was a standard and the other 2 were, one group was the standard and the other group was the low input, we processed differently in the first day. So we have the assistants work after the demonstration of the teachers. They process the sample with the weighting all the samples to have around 100 milligrams. Sometimes it was a little more, sometimes it was a little less than 100, but it was around. And after that, they used the liquid nitrogen to make the tissue like a powder, because we needed the material like a powder. You know, everybody know that, to go and to process the first day. Right? So they do all of this process to the first 6 samples here. And they're using the liquid nitrogen. They have a very good powder material. Yeah. No. and the other 2, the protocol, it was different because the amount was, one of them was 40 milligrams, sorry, and the other one of the krill was 40 and one of the other krill was 30 milligrams. So after weight the tissue, we were directly to the fixation of the material with the formaldehyde, and it was different to the other group because they powder first, make a powder first, and then they fix the material. In the case of the 2 krill or low input, we first fix the material, and then we proceed to use the power machine. One specific tips that we confirm with Graeme, that not do a lot of time of power mashing, because can damage the tissue or the DNA. So that is one tip that is important. So maximum 30 seconds is okay. I did, because I processed the low input, and I did only 10 seconds. It was enough to have a very cloudy supernatant with some kind of material around, but very tiny. So I didn't continue with the power machine because it wasn't necessary. It was already very, very cloudy. So when we have, well, another difference that maybe you know, people that have experience with HiC, the standard input amount they process in the Falcon 15 mil, and the low input amount is in the 1.5 mil. 1.5 mil. Something that also was a little different in the protocol, it was that the material that I weighted in the low input, I weighted and I put it already in the tube of the power machine, the biomachine tubes. In the protocol said to transfer in the end. So to not lose any material, I weighted and I put already in the power machine tubes. So after that, it's just power machine the tissue in the tube already. What else? That's it, right? The first day. Well, after, when we have everything, we have to collect all the samples, and the standard input, the group of the standard input, they did several aliquots of 20% of material, 30%, right? I think 3, right? Yeah. Three different aliquots. That is they used to conserve the different samples to use again if we need it, or when we are going to start the HiC process, you are going to pick up depend of how much of pellet you need to proceed with the HiC. In a case of krill, that is low input, we proceed with everything. One recommendation is that when you're working with low input, don't do the estimating input amount. Do not lose any other volume, because you have to do the estimating input amount. You need to take 100 microliters, so it's something that you are going to lose, right? So if you know that it's low input, just proceed to the HiC protocol. In the case of the standard, of course, they did the estimating input amount, and that was going to tell us how much we are going to use in the proper HiC protocol. Yeah, the first day is the most important thing. And then they took the pen of the. Yeah, unfortunately, we don't have the table for that. But
I want to comment something.
Yeah, of course.
We noticed that, I mean, the final result is not directly correlated with the amount of sample tissue that we put in. So for example, sample 1, I remember we used around 50 milligrams and always stayed the same. And then the first cubic estimate was low, so we had to use 30%, and we ended up having the best yield for the bioaccumulated yield.
Yeah, it can be several. I think it can be several things, because we know that anything is just like a strict formula and procedures. When we do the calculation, we have.
No, but for the plan, they did the libraries, they work, and then we really correct. I mean, there's some kind of variation.
It is also the hand, right? I mean, we are practice here.
And the day. It's before holidays.
Yeah. So I don't know. Sometimes we don't know what happened. Sometimes it just happened, and if you have to spend more money to figure out what happened with what sample, that maybe it's not too important. I mean, it's just one sample or two. For me, that I was working closer to production, really is we are not thinking or break our head for 1 or 2 samples, because we have 45 in 1 week. So you can't stop the one sample. At least there is a very complicated sample that is not going to production, go to technical team and try to think how we are going to resolve it. Right? So yeah, I think you are right. Then another comment. Then we start the HiC protocol with the correct amount of mass and yield and everything. Well, I can comment the most important thing that I consider for me, right, during the process, because then I have to maybe talk with the production in my team, right, about the time, the time of every mix, what is more important than other. For example, the conditional solution is very important to stop at 20 minutes. We can go to 20 minutes, but in our case, in the protocols at 10, but you can go until 20 minutes. But for us, that we are working with 16 samples at the same time, doesn't make sense, because when you stop at 20 minutes and you are processing by hand in 1.5 tubes, that is the way that we are doing now the process. At the time that you arrive at sample 15 is more than 20 minutes. It's maybe 30 minutes of conditional solution. That's not It's not recommended. I learned that this week, right? We are not doing 20 minutes, we are doing 10 minutes. So I think we are safe processing that. Yeah. What else?
But one way to get around that, you got to look at one.
Yeah. Yeah. So now we are trying to move to strictive. And we didn't do yet because we had that problem of the estimating input amount that was something that we are going to change, because I don't know why we were working with the 100 microliters of the estimating input amount. And in the first, during that process, you have to pellet the 100. You know, if everybody remember that. When you have your big pellet and you have the tube with your estimating input amount, you have to pellet all the samples. In our group, we were working with the liquid, not with the pellet. So in the end, we had 300 and something that is not fixed in the strip tube. So that is why we didn't change to strip tube. But now the problem is solved. We're going to change that very easily. Well, yeah. And then we have this result. Our cubic concentration, it was 5.75. And it was the QC1, right? This is the QC1, yeah. And we have a good deal, and all the samples passed. The QC1 of the sample number 3 was 17. It was the lower that we had, but it's still, well, considering the Arima recommendation, the sample passed anyway. I mean, the sample passed. And yeah, any other comments? Morten? I think we can do a lot of comments, but I don't know.
Yes, no, I think we covered it well. Does anyone have a question about the things that we doing? I mean, the question you had about that low input sample was the kind of a lowest one, but also had the highest QC1 value. Yeah. Doesn't need to be that important really, because although it was low in the estimate input, you kind of boost up the input for the real effect, right? Mm-hmm. So if you 3 times more there, you use the 30% pellet on that one, so we kind of even out the input a bit between the samples. So I think it's just a coincidence that these one higher than the others, and the most likely reason is that this pellet was treated well during the crushing and through the rest of the process.
Yeah. Also, I think always it's important that the experience, right? If you, I mean, I know someone from the group of Graeme, for example, that work every week, Amy, every week with the power machines. She's an expert working with that. And so if another new person is working with the power machine, it's going to be a bit of change. And I think the first day is the most important day to obtain everything, to capture everything that you can, and also the fixation, right? So there are differences, but I always consider that when you are doing for the first time, you're going to have some.
So you can expect such a differences normally.
Yeah.
In the same sample.
Yeah.
In the same kind of sample.
Depending on who is processing. Yeah.
Let us exclude the outliers, the low one and the high one.
No, yeah, the other ones are more or less.
What are we left with, right? Yeah. And think about that. We have been prepping these samples individually, right? So if I were doing those from the start, I would do all of them, right? I would use a multi-channel pipette when I can, basically. So the result would certainly be more even than this. I'm pretty sure. But overall, it is a very good result.
Yeah. All the samples were very good.
So you did a good job, so be proud.